Hello, everyone. Thank you for joining today's webinar on selecting on factors to consider when selecting a field monitoring system. First of all, I hope everyone is staying safe. I am Richard Rodriguez. I'll be your host or presenter today. And I just joined Onset this past October to lead market activities for outdoor and agricultural products, along with my colleague Paul Gannett, which I assume if any of you have joined webinars in the past, you may have attended one of his webinars already. My focus has been in developing our agricultural strategy and roadmap, while also helping improve our presence in the research and academics area. One point to note, like many of you, I expect I am working from home today with daycare closed and my wife being a nurse and needed at work. That means I'm hosting this webinar while hoping that my 2- and 4-year-old daughters don't cause too much of an interruption for us. So please excuse any little voices you may pick up in the background, or hopefully we'll stay away from any shouting matches for the next 45 minutes or so. Some housekeeping info. This presentation is being recorded, and it will be you will be able to access it in the next couple of days. You should get a notice from our marketing team on how to access that recording. Also, regarding questions, thank you for anyone who has sent in questions ahead of time. I did try my best to fit those into the presentation so we can get through those as we go along. If anyone does have any additional questions, or you would like further clarification on those questions you have already submitted, please enter them in the Q&A tab at the lower portion of the GoToWebinar control panel. I'll do my best to address as many as I can at the end of this presentation. So who we are and what we do for anyone new to Onset. We have been making data loggers and sensors since 1981. We are located in Cape Cod, Massachusetts, where we develop and actually build all of our products. Actually, our entire operations are really run out of here with sales, customer service, and all other aspects of the business being run out of here. So anytime you call our hotline, 1-800-loggers, you will be talking to someone in beautiful Cape Cod, Massachusetts. And for topics today, we'll I'll do a brief introduction to wireless field monitoring systems, talk about the climate-based, or several of the climate-based tools available. We'll cover the benefits of these systems, and then talk about single station versus sensor networks, and when to select one over the other, and then we'll get into those factors to consider. Just to clarify, I know we have a quite diversified number of folks here with different markets and interests. I do know we have quite a few of you with indoor applications that join, so I will talk a bit about that, as you can see when we touch on the benefits of monitoring remotely. However, we do have another upcoming webinar this coming week that is basics of monitoring for indoor applications. So that's something that I also suggest you consider joining. With that, what is a field monitoring system? So why should you care? It is basically a system of tools that uses both hardware and software components, and likely a telemetry unit, or the ability to record and transmit this data remotely that will enable us to monitor environmental conditions in the field. And some of these instruments would include or measure different conditions such as soil moisture, temperature, relative humidity, water level, solar radiation, wind, rainfall, and then you can actually incorporate different calculations such as evapotranspiration. You may also add other sensors that we don't have listed here, with some systems allow you to wire in different devices that you may have, depending on the input or output they have. You can also roll those into stations such as what we offer. An example of this, we typically get requests to be able to integrate, a motor to understand if it is on the on state or off state. And why consider remote monitoring systems? So basically, remote monitoring systems enable you to provide near real-time environmental data or collect near real-time environmental data remotely. This is great for hard to reach places, remote locations, or large areas to cover. So something where it would be impractical for you to go location to location there we go with a little bit of a shouting match going on in the background. Let me get back. So where was I? Anywhere where it would be impractical for you to travel to in order to monitor these conditions. These systems can alert you, provide you email or text message. Remote monitoring systems, again, allow you to monitor different locations remotely, which provides you real-time environmental data, which can be great for hard to reach places, remote locations, or really large areas to cover where it would be impractical for you to go around checking device by device. These can alert you of critical conditions in specific points in the field. So if you're interested in knowing whether temperature dips below a certain threshold or above a certain threshold, you get a text message or a text message or an email alert. You can ensure that data collection and devices are running as expected. For years, users of these data loggers have just had to trust that everything's operating as expected and as planned, where now you can actually check in on the device, ensure that the device is running properly, the battery health is okay, and will run through the duration of your needs, and that you didn't actually have a wild animal come by and destroy the device, which is quite a common occurrence in some locations. You can even get a head start if you're working on a research report. You can get started on a lot of that work by viewing data as it's being collected. I can help you with your trust on where your work is headed, and you can even plan operations and priorities. Whether you're working on a farm, in a greenhouse, or a warehouse type activities, you can plan different operations and activities daily. So now specifically for growers or farmers, the right field monitoring system can help you reduce costs associated with irrigation by allowing you to water only based on plant demand, plant needs, as opposed to just your fixed schedule. You can protect crops and workers or cattle from excess cold or heat. A very common use for our products is frost protection, which again, you can set different temperature thresholds, so you get an alert when temperatures dip below a certain threshold, and you can use these then to confirm that conditions are okay for you to deploy certain countermeasures for frost. Can help you protect from pests and disease that flourish when specific climate conditions are seen. If you're spraying, you can confirm that when conditions are acceptable for spraying, that wind speeds are between that 3 and 8 miles per hour recommended, for example. You can do crop planning. We have several customers that like to deploy our equipment before deciding where to plant certain crops or what types of crops to plant. They like to confirm that conditions will be okay for these selected crops. We actually partner with NEWA, which I'll cover in a little more detail in a few slides, where they did a survey for users of devices such as what we offer in terms of remote monitoring weather stations, and when paired up with their services. And in 2017, their survey found that on average, you saw growers saw $4,300 or a little over in savings from reducing sprays. They were some counted up to over $33,000 from avoided crop losses, and on average came out to over $2,000 per acre savings on average, with 75% of respondents saying that they actually saved on their spray bills. For agricultural research, again, remote sites are difficult or impossible sites to get to at times. That can pose a challenge. You can there can be a concern due to in terms of data loss due to catastrophic damage of devices. So again, you can one, get that data as it's being uploaded hourly, daily, every few minutes, whatever you decide, as opposed to having to arrive at your test site and finding out that there was that your data logger or sensor was damaged. Unfortunately, that is whether it be wild animals or just some people with using them as target practice is actually a common occurrence for researchers. Then in environmental monitoring does extend into indoor type applications. We do offer several options for monitoring air quality, typically used in hotels and workplaces such as offices. They're often used in HVAC testing, or just to confirm that everything is running smoothly with HVAC. We also have popular products for ensuring air quality and the preservation of highly valuable items such as libraries or museums. We've actually recently introduced HoboNet Indoor for more demanding applications in terms of distances and environment. So we took our outdoor products and made a few changes, basically to remove some cost out of them to make them suitable for indoors. As you can see in your picture there, you have a wireless sensor where it differs from an outdoor version in that it doesn't have a solar panel. So these another common application, actually, what we have featured there is just monitoring the environment for temperature and humidity in a warehouse. So if you're working with sensitive items such as electronics and some apparel, this could be, especially now where a lot of folks are working from home, working remotely, you can keep an eye on your space. Just a couple of years ago, actually, one thing that comes to mind with schools now closed is that a neighboring town built a new school, and that school was closed for a few months waiting for the new school year to start. And basically it was empty for a few months, and went through the summer months with high heat and humidity. And when they went in to get the school prepped for the new school year, it was found to have mold issues. So an entire wing of the building had to be refinished, walls ripped apart, and almost rebuilt. Alternatively, if you're worried about real cold weather impacting pipes, causing damage to pipes during freezing, that's another thing that you can monitor. So by deploying these devices throughout sensitive parts of your building while working from home, if you're a facility manager, you can ensure that everything is operating as planned, that the temperature is where it should be, that the HVAC units are working, or if you're trying to cut back on energy, that you're not allowing any undesired conditions. Now, before we get into the factors to consider, I want to look at single station versus a sensor network. And when selecting remote field monitoring station, you've got two different options, and with them you'll have, when you're planning the future possible expansion, you'll want to take into account anything you may want to do in addition to what you start with. So a wireless weather station refers to the ability to monitor data, or a device that will monitor weather data remotely. Again, as discussed, and it will include really these are built a la carte, but commonly you'll want to measure rainfall, solar light, temperature, relative humidity, wind speeds, wind speed and direction. Now, in addition to this, now one advantage of having these on your field, if you're farming, for example, is that you know the conditions specifically on your field as opposed to what the conditions are at an airport 20 or 30 miles away. Wireless sensor network, on the other hand, takes that weather station and gives you the capabilities of adding additional sensors throughout a wider field, so that if you have any other points you want to monitor and more specifically, such as temperature or soil moisture, you can deploy these sensors to get a read at the microclimate level. Again, especially if you're looking, if you've got varying terrain, that can be a cause for some changes in what you would expect. So if you've got a nice plain field, like you see in the picture at the top, no changes in topology, no changes in elevation, no slope changes, soil is relatively consistent. One weather station with different wire sensors, getting all this data off of one point may be sufficient for you. However, if you've got terrain with the changes in elevation, changes in slope, so the sunlight will vary, soil type varies, you may want to be able to add the capability to have specific measurements at different points so that you can understand how conditions change, especially in terms of temperature. You know that cold air flows like water, so it will flow downhill and tend to accumulate in pockets, low-lying areas, or anywhere there's a large obstruction that impedes airflow. You'll get colder temperatures. One great example of that are cranberry bogs. We have a lot of cranberry growers in our area. And cranberry bogs sit just a foot or two below the road level, and that change in height can lead to a pretty significant difference in temperature from the road. We have one of our customers that talks about having some of his bogs within 11 degrees Fahrenheit below the temperature measured on the roadside. And that, again, is just because of that foot or two difference in height. And finally, factors to consider when selecting a field monitoring system. So we'll cover 10 general. We should move relatively quickly through these. The first, connectivity. So in terms of connectivity or communicating data collected to the internet so that you can view that, you have several options, as you could expect. So depending on location, Ethernet and Wi-Fi may be an option, and then cellular and satellite solutions are also available. I did get a question ahead of time regarding whether or not we offer any Wi-Fi sensors or systems. Our sensors themselves are not Wi-Fi enabled, but our stations are. We do have some stations that you can connect either through Ethernet or Wi-Fi, and then they collect data from our wireless sensors and upload that so that you can view those remotely. Big advantage there is that you don't have to pay for a cellular data plan. Now getting on to satellite. The advantage of satellite is that it really gives you connectivity virtually anywhere. There are different plans or different options. One that is actually global. So if you look at an Iridium option, it will give you the option to deploy stations in Antarctica, in the North Pole. Something like Inmarsat would not. It would limit you a little bit at the very far north and south. These do come with higher data costs, so it is important to select not just the right device, but the right plan. You want to make sure that you select the right amount of data and ability to avoid any added data charges. I did get a question here. We work in offshore ocean about 50 to 100 miles out, flowing currents. Do you have any way to transmit data? I would expect that the satellite solution would probably be your only option there. Similarly, I got another question regarding very remote locations with high humid climate. If that means that you don't have a cellular connection there, then the satellite option would also be possible. We don't currently have a satellite solution offered on our website. We are actively working to add that. I hope to be able to share more details in the next coming weeks as we're just finalizing some details on how that will work. But I will be sure to have someone reach out to you folks with more details on that. Ease of deployment. You want to understand how easy it is to deploy these devices. The stations are quite easy. They're typically easy to set up, but you also want to understand how easy it is to connect wireless sensors or wired sensors for that matter. Typically, for wired sensors, you've got some that require programming, while others, such as one key differentiating feature for onset hobo devices in terms of our plug-and-play sensors. You plug them in and they're ready to go. They self-identify. Then when you look at the wireless devices, understanding how to pair them up with a specific data logging station that can be time-consuming if you don't choose the right, if you don't take that into account up front. Typical methods used are a push button. That's common, probably the easiest way. So as you see on the image there to your left, or to the left of your screen, that is a HoboNet wireless device with a single button. There's just one button to push. You push that down, hold that down for 3 seconds, and it begins pairing itself with the station. That's as hard as it gets, really. Several manufacturers offer an app, a mobile app that you would use to configure these devices. Also makes it relatively easy, though I haven't gotten into everyone's app to test them out. But we're all accustomed to using apps. It just would require you to download an app onto a mobile device and go through that setup one by one, which I think it's easier to assume that it may take a while longer than pushing a button for 3 seconds. Also, depending on where you are located globally, downloading these off of iOS or Android may not be very easy. There are some that require dip switches, similar to how you would program a garage door. And then there is the real programming, where you would need a computer science degree almost to figure it out. And then for still an ease of deployment, mounting. You want to understand how easy it will be to mount these. Depending on where you're deploying these, you may have a large number of mounting options available. But sometimes, whether you're on a farm or out in the, on a mountain top, trying to get real remote readings, you may have to carry additional equipment, posts, or whatnot. So you want to understand what your options for mounting are. Size and weight is a big factor to consider. Again, especially for these remote deployments. The power source, are they battery powered or are they solar powered? Do they require AC power? Integrated mounting provisions, is it easy to put a screw? Is there some place to put a wood screw into, or zip ties? Zip ties actually are a very common method, as you can see in the image there. Several zip ties used to secure the device to a post. Our devices actually all ship with screws and zip ties you could use to hang these. And security is a security concern. Again, we often hear from customers where someone vandalized their equipment, whether it be someone using them for target practice or just a wild animal coming by and getting overly curious. So you want to understand how easy it may be to hide these or keep these out of sight. Software, you want to understand how easy it is to go through the software. One thing that I'm actually proud of is how easy it is to demonstrate our software at trade shows and walk the customer through how to set up one of our HoboNet devices. So that's before making a purchase, you may want to ask if there's look into whether there's a video or some type of demo that you can do just to get a feel for how easy it is to go through that. Right now, I mean, we're all using remote working technologies such as Microsoft Teams or Zoom, so it's probably easy enough now for anyone to get on a call with someone and do a 5 or 10 minute walkthrough of software. And then you also want to understand how easy it would be for you to display information that is most pertinent to you. Can you create your own dashboards and customize it so that you can easily view the data that is most relevant to you? Or do you have to go digging every time you want to understand what the temperature at a specific greenhouse is? Can you share the data for others to view? Do you have the ability to export data? Do you have the ability to automatically export data daily or with a certain frequency? And wireless sensor coverage. When you want to understand, again, once you understand what you want to do, what field you want to monitor, you want to ask yourself, consider whether the system is suitable for that. How far from the central station can you get? So what is the maximum range? How many nodes can you add to that for monitoring? How many hops are the devices capable of? I'll get into more detail on the hops in the next slide. What frequency is used, and really the question of frequency, it comes in regard to, it references the range and strength of the signal. So for example, we use a 900 megahertz signal as opposed to the probably more commonly used 2.4 gigahertz, which has slightly longer range. However, we find that 900 megahertz signal to be less attenuated when deployed in the middle of vegetation. So in most applications outdoors, you're going to have, in the summer, you're going to have more leaves to get through, higher vegetation. So you want a signal that will be able to penetrate that. LoRa is a popular option because of its the amount of power it uses. It's low power, so you can operate these off a battery, and they have a pretty long range stated in terms of line of sight. And then we did get a question on whether or not we use LoRa devices. We do not. We chose a mesh network, radios that create a mesh network, which we found to have some advantages in terms of one, cost, and two, the ability to get around certain obstacles by creating that mesh network. And then typically you'll see line of sight ranges. Line of sight provides an easy way to compare the maximum range from device to device. But again, when you get into different bandwidths or frequencies, you get the amount of the way that obstructions will impact the signal will vary quite a bit. Still on sensor coverage, looking at a star network versus a mesh network. A star network basically allows you to have several sensors communicate directly to a central station, which then communicates all that data to the internet. This limits the range of your sensors to the radius of each device to that central station. With a mesh network, on the other hand, the sensors can communicate to each other and then to that central station. So the advantage there is that you can extend your network out by the multiplication of the distance from sensor to sensor, and the maximum number of hops you can create. So every time you go from one sensor to the other, that's considered a hop. For HoboNet by Onset, for example, the maximum number of hops you can do is 5. So given that we have a range of 1,500 to 2,000 feet from sensor to sensor and to the final location, that means that you can get a maximum of 7,500 to 10,000 feet from the central station to the farthest sensor. And that's, again, in a radius. So when you look at it overall, you can create a 8 to 10 square mile network of sensors with a single station, which means that it's a 8 to 10 square mile of 50 wireless sensors off of a one data plan. And actionable information. We want to understand if the software provides you information which can help you take action. Can your device provide battery health and before failure can impact your research? Again, you just checking in periodically. As you can see there on your screen, you get a quick view with that gives you a quick summary of the current conditions and battery life for each device. So if there's an issue, those blue bubbles with a sensor a symbol on them would pop up as red, and you would know that there's a need for you to take care of that before it impacts your research. Do dashboards show the most critical information on the conditions? If you're typically on the go, you want to make sure that you can get the dashboards that you create are compatible to be viewed easily on a mobile device as opposed to just on a desktop device. So for HoboNet, for example, we only have one HoboNet, but it does render well on a mobile device so that you can actually view your dashboards on the go. Did get a question on dashboards about functions of dashboard monitoring multiple sites at one time. With HoboLink, you can create and customize several dashboards to monitor different sensors and different sites all in one view. So basically, you click on dashboards, select the dashboard you want to view, give it a name, like top of the morning. Click that, it will give you everything you want to see before you get started on your workday. And you also want to understand ability to integrate different models, whether it be evapotranspiration, growing degree days, different plant and disease models. You may be interested in integrating your data with third-party services for maybe for weather services, crop management networks, or other software tools. HoboNet, for instance, integrates with NEWA, the Network for Environment and Weather Applications by Cornell University. So anyone in northeastern states, and actually that network extends pretty far out west nowadays, you can integrate with that service for different crop and pest models for different crops. FON, the Florida Automated Weather Network, again, also providing similar tools such as NEWA, just for Florida growers. Weather Underground, and the newly added for us, Aquarius by Aquatics Informatics, which seems to provide pretty powerful water data management software. So anyone doing water monitoring. You may be familiar with Aquarius. We now integrate with their software. In terms of alarms and alarm notifications and responses, again, we can provide alarms to inform you of system issues, or inform you that certain thresholds were hit. That they can be, soil related, temperature related, wind related. You can set up, an alarm to trigger when wind speeds reach a certain point. And these can come in two ways. It can be web-based or device-based. So in web-based alarms, basically you would have to wait for that data to be uploaded in order for the software to provide you an alarm. Alternatively, an in-station alarm would provide you immediate response. So for example, with HoboNet, if a temperature sensor senses a frost condition, it will not wait for the next upload interval, which could be, half hour or an hour away, to inform you. That device will initiate an alarm to send you a text message letting you know that you may need to get out of bed and go start your pumps. If you need to turn something on or off, these alarms may also be able to trigger a relay that will control something, an output. So if instead of leaving your home to start a pump or a fan, that relay can initiate that for you. Then maintaining historical data. So whether it be for research purposes, you want to know that your data is going to be there and safe. If you're growing, running a farm, you may want to protect yourself against future claims, or save that for in the event that you need to file an insurance claim. You want to know how long the data will be stored for, and understand if there is a cost for storing the data, and then how easy it would be to recall the data after some time. It may be that you'll plan on running your station for a few years, but after that period, and you're no longer using the weather station and no longer using your HoboLink account, what happens to the data? And when I say HoboLink, it could be the same question would apply to any other option you would have for weather station. You want to understand, what happens after that period. For the record, if you no longer have an account and you reach out to our tech support team, they can recall that data for you. Scalability. What you do today may be different or your needs today may be different from your needs in the future. So assuming that this is a permanent long-term deployment, you want to understand the possibility of scaling the network. It may be that in the future, whether your operations grow or as you become more comfortable and see more value in your monitoring system, you decide that you want to add more capabilities. It may be more sensors, or maybe you just want to integrate existing equipment, motors, pumps, into your remote monitoring system. You want to understand if those capabilities are there. You'll want to know how many sensors you can add per station, what the cost of adding those sensors would be, what the both from a device cost point of view, as well as any impacts on data or recurring fees that you may have. What is the maximum range for this network? Will it ultimately enable you to cover the entire area that you want to cover? And then what is the maximum number of sensors and data channels? And for total cost of ownership, there are several costs to consider. Of course, to start, there is the cost to purchase the equipment, And a lot of when it comes to simple remote monitoring systems, for the most part, we all make those prices known. They're all advertised online, so it's somewhat easy to compare. Then you have different annual costs or recurring costs, such as cellular data plans. There may be web hosting service plans. Typically, a data plan would be required for each gateway or each station. You want to understand if there are additional costs per node or sensor, any additional costs for software features or data archival. Software upgrades, do those come for free, or do those require you to pay for them? Are there any other recurring fees that perhaps not mentioned here? You typically see, in terms of recurring device fees, there are some players there, that may charge, in addition to your data plan, they'll charge a fee per device. So it's like you buy the device, but then you pay a recurring fee. You see these in some manufacturers using LoRa type devices that I've come across. Others where you may have nodes that we refer to as nodes, where you plug in a bunch of sensors and then those communicate to a station, and then that uploads your data. Sometimes you'll have, in addition to your central station data plan, you'll have additional recurring fees. If you're looking at a system like HoboNet, and I think it's fair to say a couple of others that are probably closest to us, you would have basically one data plan. You purchase a product, and then you have, based on the number of sensors you have, the expected traffic of information, you would either be in one of three plans: our basic plan, our standard plan, or our high data plan. So you're talking about a range of $150 to $350 per year. And then other costs may come in terms of maintenance. Are there device maintenance costs, such as calibration checks that you have to do? If you have to replace a sensor, what would the cost of that be? So you want to understand how durable a sensor may be. There are some very low cost sensors out there. So if you think you're going to do a deployment and be okay with replacing it in a year or two, that's fine. If this is a long-term solution you're looking for, you may not want to have to deal with the hassle and the cost of having to replace these. You may, a little more research may be warranted to find something that is more durable. An example of this, so actually we just recently launched a new sensor. It's actually a soil moisture, temperature, and electrical conductivity sensor that we just added to our website. And to help you understand, how important it is to not just look at a specific device and its cost, I put this view together of what two different scenarios would look like. So if you were to buy one of our remote monitoring stations with wireless sensor capabilities, you're looking at $770, for example, plus the sensor itself, which you see up at the top there. You're talking about $450. So your total, excluding data, would be $1,200, a little over. Competitor X offers a similar station and a similar sensor. Their total price comes in at $875. The key difference there is that their sensor is wired only. So when you look at the example and this is for a single location. So say you want to measure one point and nothing else. If then you say, you know what, I'm measuring soil moisture here, but I want to know how it varies throughout the field. And let's say you get to 3 sensor locations, single depth, and again, with a cellular connectivity. With onset, you can still do that with one cellular station. With competitor X, that would require you to have 3 stations because they're only wired. and 3 sensors. So the total cost would come for OnSet's HoboNet would come in at just over $2,100, where for our nearest competitor, it would be $2,600. So right there, you see, if you understand what your actual vision is, what you want to do, and don't compare just device to device, you'll hopefully save yourself a lot of money. And here, again, I am excluding data plans. So our data plan not only comes at a lower cost than our competitors, but because they require you to have 3 stations, that means 3 different data plans, which really increases that difference. So again, when you're looking to select a wireless sensor network, make sure you're accounting for what you will want to do in the long, over some time, and get a quote for that. Put that full scenario together. Similarly, I did get a question an hour or so before this webinar where someone asked what the lowest cost option would be for remotely logging data for temperature. And I put the scenario together. So our micro RX station, which battery powered, costs $560. Solar powered costs $620. Our temperature sensor, the wired version, would run you $95. A 1-year data plan is $150 for that. So your total would come in at under $900. And finally, who owns your data? Is data for your use only, or is your data going to be used by a third party? It just so happens I stumbled across this when looking at a couple of newcomers, high techy type. Actually, these were specifically agriculturally focused sensor providers, which seem to have a low cost sensor solution. However, they are using their users' data in order to basically fund the cost of the product. So they somehow use the data and sell it to third parties and use that to again fund the cost of these devices. In terms, if you're doing research, this is likely not something that you would be okay with. So it's just one more thing that for you to consider, perhaps a quick, simple question to ask on what the company's policy is in using their customers' data. And with that, we've reached the end. I will now answer any other questions. As I admit, I have a little 2-year-old at my foot, so try to regain my focus. So first question, we are looking for meteorological stations for Antarctica. Would you recommend one? The wind speed can reach more than 40 knots. So in terms of telemetry, so being able to connect to it remotely, our systems do not, we don't currently offer that option. We do have, if you're going to be there or have people present and your plan is to just have offloaded the data yearly or whatever time locally, then I can make a recommendation. I did look into this. Our ultrasonic wind sensor does work well in tough conditions, but it does require solar power. And given the low angle of the sun through much of the year there, I would suggest that you take a look at the RM Young Alpine anemometer. It's built for icy conditions. It's got a special black coating that's meant to, I guess, melt the ice or keep ice from forming around it, and it's got built-up bearings, and this can measure wind speeds up to 225 miles per hour. If you do like the Hobo solution for data logging, we do manufacture an adapter to allow you to easily connect the RM Young device to our product without any hassle. If you have any trouble finding that, please feel free to reach out to us and we can help you find that. Can you employ, oh, I'm right up against the time. It's almost 12 o'clock. I'll keep going for a few more minutes. Hopefully many of you can stay on. Can you employ a passive sampler during online monitoring? If yes, which ones? I think, I'm not sure, I'm completely sure of what you're referring to, but we do, if it's regarding collecting average values over time, we do offer that capability where the sensor will collect data and then transmit just average or calculated values. Is there a remote data logging possible for buried sensors? Is that data sent to satellites? I'm not sure what specific sensors you're looking at or referring to. But we do, several of our sensors are buried, meant to be buried, whether it be for temperature sensors or soil moisture sensors. The sensors themselves are buried. The radio is left outside above ground, and that communicates data to the telemetry unit or the data logging station, which uses a cellular signal or Wi-Fi. Is it possible to record both static and pumping water level of irrigation well? Yes, I think I understand that. Water level can be measured and based on, you set the upload rate for the data. So if you can actually monitor that while you're pumping. Interested in remote monitoring of methane gas and radon gas. We do not, unfortunately, we do not offer any sensors capable of measuring those gases or detecting those gases. Does it measure light and regarding the light measurement, we offer two light measurement devices. We offer a PAR spectrum for plant science, and we offer a wider range spectrum. So we have two devices there. How far apart can wireless sensor network stations be? Again, that varies from manufacturer to manufacturer. For our devices, you're looking at 1,500 to 2,000 feet from device to device. And then again, with 5 hops, that can, from the central station, you can get up to 7,500 or 7,500 to 10,000 feet away from that central station. Could you repeat how the Wi-Fi connectivity works? The data logging station, our RX3000, is the only one capable of doing this. We have the option for Wi-Fi, and that would basically connect to your local Wi-Fi device, and all the other sensors would connect to it, and then based on whatever frequency you want to upload data to our cloud service, that station would use your Wi-Fi signal to get that data uploaded. Can you create a floating data collector that communicates by sat? I'm not completely sure what you mean by that. We'll have to get back to you on that one. Do you have a wireless solution for measuring coastal water surface elevation, salinity, and temperature for the same period of time with one unit or multiple units? I'm not a water expert, far from it. So I may have to have someone get back to you with that answer. We do have options for those measurements in separate units. Well, water depth and temperature would be in one. Salinity would be its own. Does Onset offer a soil temperature sensor? We do. We actually we have a couple of options. You can use our standard temperature sensor buried at whatever depth you desire, and then we have a new HoboNet for HoboNet specifically, so it's a wireless sensor that measures both soil moisture and temperature. It uses the Teros 11, pretty well known sensor, so it's a HoboNet Teros 11 and it again uses the meter group Teros 11 soil moisture and temperature sensor. We do have a third device that can do that as well, the Teros 21. So it's a soil water potential and temperature sensor in one that is capable integrated into HoboNet. Is a software PC-based or web-based? Many governments prefer data to be localized. So for we have both options. So we do for local offloading, we do have software that would be PC based. However, for this remote monitoring, it is all cloud based. And we use Amazon Web Services, so that data is stored in the US. Do your loggers have an SDI 12 port? Use a profile soil moisture probe. Do your remotes have enough power to run them? So we actually, the 3 soil moisture sensors we just added this month, we actually have a webinar on this next week for soil moisture. They're all SDI 12 soil moisture sensors, and yes, battery power was the concern there, but they are operating well. In terms of a profile or multi-depth soil moisture probe, that is still a few months out. Can we integrate third-party sensors? Like if we have, yes, in terms of integrating third-party sensors for our RX3000 station, we do have the option to add an analog module with a 420 milliamp input. So any third-party sensor with that type of output can be integrated, and then it would just require you to do the scaling, which you can do easily in HoboNet. I'm sorry, in our HoboLink cloud software. Can we connect them for real-time monitoring? You can have a HoboLink automatically send data to an FTP site, for example, but you can't wire the device in directly to another system. For a single wire station that is in shady location, can a solar panel be positioned elsewhere and still used? How far away? You could, our cable, you'd be limited by the cable length, which is not very long, I admit, but I guess you could always extend that cable length. We do have, you may want to reach out to our technical support team because we do have often, we ourselves will deploy our own stations in shady locations just to see how much light is actually needed. And these devices don't actually require a lot of power. So even in shady locations, they may work. We do have options for larger, we have 2 external solar panels, which can be purchased separately, a 5-watt and a 15-watt. You can always go with a larger, opt for the larger panel, which may also help you out there. Can the data output be converted from graphs to dials or gauges for appearances? Yes, when you create your dashboards in HoboLink, you can actually display the data in dials. You have dials, gauges, thermometer type views, and of course graphs. Is the new soil moisture temperature EC sensor designed to be buried or installed on soil surface? Our new soil moisture temperature and EC sensor is designed to be installed buried. So you would want to bury that at whatever depth you're interested in measuring. So even if you may have 2 or 3 different depths that you want to measure these at, and they would be installed at those depths. If you want to measure it close to the surface, then you could just bury them closer to the surface. But they are actually designed for long-term deployments in pretty rough conditions. So they're meant to be out there and buried. And it looks like that is it for questions. I want to thank everyone again for your time today and working, your patience in dealing with our technical issues, and also the little voices in the background here on my end. Thank you again, and I hope to hear from everyone soon. Thank you.